Trevor, I can't hear you. Trevor, I cannot hear you.
Ah, there we go. Better?
Yes.
Hey, sorry about that.
Hey, no problem.
That's why nobody said anything when I asked if you could hear me.
Yeah.
I'll be quiet.
All right.
All right, thank you. Okay, let's try this again. Today, we're going to be talking about promises. Promises are an alternative way of handling asynchronous code. So callbacks is sort of the classic way to handle that. Promises are an alternative to that try and provide a more readable, flexible way of dealing with asynchronous code. So a promise, what is a promise? A promise is an object that represents the eventual completion of failure of an asynchronous operation and its resulting value. So it is an object, and it bundles up this concept of like, I have this code running that is going to finish at some point in the future, or maybe has already finished. It bundles up that code and that sort of running action and the state of like whether it's finished, if there was an error, whether there's an error. And promise has two really important methods on it. Then, which allows you to sort of register a callback that will be called when the promise is fulfilled. So when the code finishes successfully, then any callback that you've registered with the then method will get called with the result. And there's a second method called catch, which is similar, but it registers callback to be handled on rejection. And this slide is wrong. This should say on rejection. So, and we'll look more into like the implementation details of that. But first, let's look at the problem that we're trying to solve with promises. So imagine a case where you have like 4 methods you want to call in order. If these methods are not asynchronous, if they're just synchronous methods like this do sync 1 through 4, then calling them in order and handling errors is pretty straightforward. And in this case, we're assuming that we want to take the result of one method and then use that as the input to the second method, and then take the return value of the second method and pass it into the third method. So you're sort of like piping this result through 4 different methods. So this is pretty straightforward, right? We just let a result value and we call doSync to get the first result, and then overwrite result again by calling doSync2, doSync3, doSync4. Do these 4 things in order, log out that we're done, and if there was any error in any of that, we can just wrap it with a big try-catch block and call some error handling function. So for synchronous code, that works great and is pretty easy to follow. To do this exact same thing in the case where all 4 of those methods are asynchronous methods that take callbacks, your code looks like this. So this is accomplishing the same thing. It's just doing it asynchronously. And as you can see, it's a lot more code to express the same basic idea. And the code is sort of creeping further and further away from the left margin here as like these indentations get deeper and deeper. So in each of these, right, we have, we call the first, function and we pass it a callback, and then we have to handle the case where there's an error and, call the error handler. So there's another if-else block and we're indenting again. And then we get to call doAsync2, passing in the result we got for the first one. And then the whole thing repeats, right? And then we've got to do another callback function and check for an error again and call the error handler, and then push into an else and then call the third thing, and on and on and on until we get all the way down to the middle of the callback in the else block for the 4th call, where we can finally log out that we're done after checking for an error one more time. So this is pretty complicated, and this code isn't actually doing anything, right? We're just passing value from one function to the next and logging out console.log done. So this kind of structure is one of the things that promises are trying to solve for us. Like, how do we write this code in a simpler way? Promises give us a way to do that, to turn the previous code into this, where if these functions, instead of accepting callbacks, returned promises, then we could do this. We call doAsync1. It's going to return a promise. And then we can call the .then method on that promise to say, okay, promise, whenever doAsync1's work is complete, then take that result and pass it to doAsync2. And the then method will return another promise that's linked to the callback that you passed into then. So when this doAsync2 returns a promise, it'll also get returned from this then method. So we can just chain these thens together. So the first then will run when doAsync1 is complete. The second then will run when doAsync2 is complete, and it'll get that result. So it's a lot more straightforward, right? Just do the first thing, and then the second thing, and then the third thing, and then the fourth thing. And then we can specify the error handling once. At the end, we can say .catch. And any errors that get thrown, if any of these promises, if the code executing inside any of these promises encounters an error, throws an error, then the promise will be rejected, and it will call any handlers we registered by saying .catch. So we're registering one handler here at the end saying, okay, if there's an error in any of these, call this function, which will take the error and just pass it on to our error handler. So you can see, right side, left side, which code would you rather come in and have to debug? And that's what promises are getting us. So that's sort of the motivation for promises. So what do they look like on the inside? So promises have kind of 4 things that you should know about. The first is this executor function. And that is the code that the promise represents. That's the work the promise is doing. It's the thing that is either going to succeed or fail and trigger the other handlers getting called. And the promise at any point is in one of 3 different states. Right now we see this promise is in the pending state. Pending means that the code's still running and hasn't finished yet. And then these fulfillment and rejection handlers are just lists of callback functions that got attached to the promise when then or catch was called. So whenever you call then, you're adding a function to this list of fulfillment handlers. And whenever you call catch, you're adding a function to this list of rejection handlers. And at some point, the executor function will complete one way or another. It'll either, fail with some error condition, or it will succeed and produce some result. And at that point, the promise then changes its state to either fulfilled or rejected, depending on whether the promise succeeded or failed. And it will call the appropriate handlers. So if the executor succeeds without error, then the state changes to fulfilled, and all of the fulfillment handlers will get called with the result of the executor function, whatever that was. And if the executor function fails for some reason, an error gets thrown, then the state of the promise gets moved to rejected, and all of the rejection handlers get called. So let's look at this with some code. So to take an asynchronous function, to create a promise from asynchronous code, you would do something like this. You create a new promise object, and the constructor takes one argument, which is the executor function. And the executor function takes 2 callbacks. So it's an asynchronous function, but it accepts 2 callbacks instead of just 1. It's got a separate callback for when the function resolves, so for like the successful case, and a separate function for rejection if there's some sort of an error. So if we had just a traditional asynchronous function like getUser that's going to go fetch some user from the database by ID, given this asynchronous getUser function, we could turn it into a promise by putting it in the middle of an executor function, calling it, and then in its callback, checking for the error. And if there's an error, we're going to call the reject callback with the error. Otherwise, we're going to call the resolve callback with the user. And that becomes our executor function. And so the promise gets created, the state gets set to pending, and immediately this function gets executed. So get user starts talking to the database, and at some point, the database will get back to us with that user. And if it was successful, we'll come in here and this resolve callback will get called. And that's what triggers the promise to change its state to fulfilled and start calling all of the fulfillment handlers. Yeah, I think that's all I want to say about that. There's one more wrinkle in here actually, which is that with a promise, you can keep adding rejection or fulfillment handlers. And because things are happening asynchronously, it's possible that by the time you get around to adding a fulfillment handler, by the time you get around to calling .then, the executor function has already finished. And the promise will gloss over that for you. If you add a fulfillment handler after the promise has already been fulfilled, then that fulfillment handler will just get called immediately with the result, whatever the result was of that promise. Cool. Any questions about that part of it? We are going to go and actually look at some code. But just on a conceptual level, any questions so far? Oh, I should check the chat. I'm forgetting about that. Okay, no questions in chat. Just holler out. I've only got the one screen today, so you may have to unmute and holler at me to stop me. I can't see the chat all the time. All right, so let's back out of here and go look at some code. So what we're going to do today is actually basically re-implement the built-in, the promise library ourselves. So you kind of see how promises work. And they're sort of built into modern versions of JavaScript. It's just like a date object. It's just there for you to use. But what we're going to do is actually build our own. Not because you'd really ever want to build your own promise library, although someday you might. But there are some really good ones out there. And again, it's built in. But we're going to build it on our own so that we can better understand like exactly what's going on. Because it's actually not that difficult to re-implement the promise library. And hopefully that'll give us a better understanding of exactly what's going on. So the first thing we're going to do is write some tests so we know whether we're doing it right. And initially, I'm just going to run these tests against the built-in promise library to sort of make sure we understand how it's working. And then we'll just replace it with our promise library and see if the tests still pass. So we're describing a promise. We're using Mocha and Chai. And we know that the promise is going to call the then callback on success and the catch callback on failure. So let's see what a test for that would look like. So let's create some promise, new promise, new promise. And then we'll write our executive function, resolve, reject. And to keep this really simple, we're just going to take the resolve method, resolve, and pass a value to it, 42. So this executor function just immediately resolves, right? Which is fine. And then here we're going to say p.then, so when the promise is fulfilled, take the result, and we're going to expect result to equal 42. Done. So there's a test for the happy case, right? And the testing catch should be really similar, right? You can do the same thing here, but instead of a promise that resolves immediately, let's try one that rejects tests immediately with some error. And then we can change it then to catch error and then expect the error to equal it broke. So let's see if those tests will run for us. npm test. Great, 2 passing tests. That's fantastic. And just to make sure I didn't do something really silly, let's make sure the tests do fail when we need them to. Yeah. Timeout exceeded, unhandled promise rejections are deprecated. Right. So we've got 2 tests there for the promise. It'll kind of get at that basic behavior, right? So let's see if we can write a promise library that passes these tests. Let's go stick it in, create our own promise. We'll set that equal to require, and we'll just put it in an index file in the same directory. So now if we run these tests, promise is not a constructor, right? Because we've overwritten promise with something else that is not a constructor, probably undefined. So let's go and take a look at index.js. It's just an empty file. So let's write a promise constructor. So function promise. All right, so we know that a promise takes an executor function, executor function. And then we know that it's going to call that executor. Why do we got to do things I can't spell? It's going to call the executor function, and it's going to pass in these resolve and reject callback functions, right? So what are those going to look like? Oh, we also know that this dot state, right? So it promises a state that we said starts as pending, because nothing's been run yet before the executor function starts. So we're going to do that. And let's make these resolve and reject methods. Well, let's just start with what we got here. So resolve and reject, we need to define those things. What would that look like? Const resolve equals, so we know this method is going to get called with the result of the executor function if it's successful. So the first thing we know we can do is set the state of this object to fulfilled, right? And then we want to take any this dot on fulfilled. So the object should have some list of unfulfilled callbacks, right, that are going to get added by then. So we want to do something with those. I'm going to just gloss over this part for right now. We're going to say call all unfulfilled callbacks, right? So that's what our resolve method would look like. It's going to set the state, and then it's going to call the unfulfilled callbacks. And then we're going to have another one of these called reject, reject. And that's going to get called with an error, right, by our executor function if things go wrong. So we'll set the state here to rejected, and we will call all the on reject callbacks. So that's a good start. There's some pseudocode. Our tests are still going to pass because we still have to actually implement this stuff. But we need to figure out where these onFulfilled and onReject callbacks are coming from, right? And those are coming from here, the then method, right? We say promise.then, and we pass in this onFulfillment handler, right? That's going to check to make sure the result is 42. And the onReject callbacks are being registered by this catch method. So we need to implement a then and a catch method. So let's do that this way. Promise.prototype then, and we'll set that to some function. And we know then is going to take a call and onFulfilled. Fulfilled. I think that's right. So it's going to take some onFulfilled callback, and let's see. Let's take this dot onFulfill, and we want to register it. We could do this, right? But that only allows us to have one onFulfilled callback, and we saw that like you can call then multiple times. So why don't we make onFulfilled an array? And we can set that up when the promise gets started. In our constructor, we can initialize onFulfilled and rejected to arrays. And then we can say onFulfilled, and let's use push, right? Push will take something and push it onto an array. So in this case, we're going to take this function, this onFulfilled function, and push it onto this array of functions. So that's pretty easy, right? And catch should be just changed in a few words. Catch, we'll call it onReject instead of onFulfilled. OnReject, rejected, I guess we're saying. OnRejected sounds weird. Let's say OnReject. I like that better. OnReject, onFulfilled. Okay, so now we've got a catch. Now we've got a then and a catch function that are sort of registering these callbacks by just pushing them onto an array. So now we know a little better what to do up here in our resolve. So call all onFulfilled callbacks. So that should look something like this dot onFulfilled. We've got an array of functions. We want to call all of them. So we can just say for each, and we'll get a callback. And we can just call that callback with result. Right? And since you know, this stabby arrow function here is a little bit redundant, right? It's creating a function that takes one argument and then just calls another function with that argument. For each, oh no, sorry. The function, sorry, the argument is the function, right? So this is the best way to write this. I was about to get a little too clever. Right, so for each onFulfilled callback, we take the callback and we call it with the result. Easy peasy. So onReject should look really similar. So onReject for each, callback, and call it with the error. So far this is pretty simple, right? We set the state and we call all the callbacks that have been registered in each case, resolve, reject. And for then and catch, all we're doing is pushing something onto an array. So let's see how close we've come here. What happens if we drop back out to a terminal and run our tests again? Promise is not a constructor. So the first thing we need to do is module.exports equals promise. I'm going to export our promise module from this so that when we're back over here in our tests, we should be getting it here. And let's see if that works any better. Boom, boom, boom. All right, so what's happening here? our tests are timing out because we never, our callbacks, our then and catch callbacks are never getting called. So why is that happening? We're creating a promise. We're passing an executor function that resolves immediately to 42. And then we're calling then and passing in a callback. So if we look at the way we've written our code, promise, executor, so here's that function that's just gonna call resolve with 42 immediately, right? We set up some state, we define these two functions, then we call the executor with these two functions, right? So what's gonna happen there is immediately the executor is gonna run, resolve is gonna get called with 42, which brings us up here. The state of the promise is gonna get set to fulfilled, and then we're gonna loop through all of the unfulfilled callbacks and call all of them. But at this point, there aren't any unfulfilled callbacks. The constructor is kind of still running at this point, right? So what's happening is our executor function is getting called too soon. And the then has not had time to run and like add that callback onto the unfulfilled array. Does everybody understand like why that's happening? Why we're seeing that behavior? Is that clear? Or do I need to say that again or say it better? Where's my chat window? Any questions about that? Okay. Stop me if you get at all lost or curious. Okay, so how are we gonna fix that? And this is the thing that we talked about before, right? That one of the behaviors of a promise is that when you say dot then, it doesn't matter, it shouldn't matter if the executor has finished or not. You can add a dot then 6 years from now, and it'll pull out that value of whenever the thing finished and just give it to you right away. And that's the behavior we need to add in here to make our tests work. So how would we do that? So that probably needs to happen down here in the then function, right? Right now, the then function is just pushing something on the unfulfilled array, regardless if the state of the promise is already fulfilled, right? So what we could do here is we could say, let's check the state of the promise. This dot state is fulfilled. So if the state of the promise is fulfilled, then do something right away, right? And what do we want to do right away? We want to actually call this onFulfilled method right away and pass it the result. So where do we get the result from? Well, let's see, where's the result? The result's up here, right? The result gets called to the resolve method, and we're just passing it right into all the callbacks that were registered. But we should store that result in the object somewhere. We say this.result equals result. Then we'll have it later. So when resolve gets called, now the state's being set to fulfilled and the result is being saved in the object, as well as passed to each of these unfulfilled callbacks. So that when we get a new unfulfilled callback at some future time after the state has been fulfilled, we can say this.result and pass it directly to that guy. So before we do the catch function, let's check the tests and see if that fixed our issue with the first test. First test is passing now. Second test for catch still has the same problem. So let's fix catch the same way. We want to do something that looks an awful lot like this. Only here we'll say on error, error. And in catch, we can add our own little if block here and say state rejected. Call it rejected, why not? Unfulfilled, and then call the onReject handler that's getting passed into catch with this dot error. Tests are passing. So that in 35 lines is the promise library. Now, if you look at the documentation on MDM for promise, you'll see there's also some handy, what I would normally call class methods for promise, where you can say promise.all and pass in like a whole bunch of promises at once, and it'll kind of run them all at once. There's some other helper methods that we haven't implemented here. But this is the basic, like, then catch executor behavior. That's sort of 90% of what you'll see of the promise library. And as you can see, it's not doing anything particularly magic. It's just a little bit of logic around plain old callbacks. And that little bit of logic lets you take the code on the left and turn it into the code on the right. So in 35 lines of code, we reduced this 24-line module to 5 lines. And we could do that to every 24-line module that has this problem. This is an example of like an amazing refactoring. It was so amazing they built it into the language, right? So that you have this built in, because it's such a common problem, common like idiom. So let's see. Now, what time is it? 2:36. Does anybody have any questions about any of this? Let's get all that code on one screen. I'm gonna flip back over to the chat. Okay, great. All right, if nobody has any other questions, then I am probably gonna wrap early. But since this was supposed to be office hours today initially, we can use the rest of the hour. We've got like half the hour left almost. If y'all have anything just like office hours, questions, general stuff you want to ask about, I'm happy to stay on and do that. Otherwise, thanks for coming and enjoy the rest of your afternoon. Cool. All right, y'all. I'll talk to you later.